Hello everyone, so in this video we have to write the appropriate Lewis structure for our species of CH3 to CHNH3+. So first we have to determine the total number of valence electrons that correspond to the given formula, and then we subtract one valence electron because we have this positive charge on our molecule. So taking a look at the structure here, or this molecule molecular formula that's given to us in the problem. So for our carbon atoms, we see that we have 2 from the CH3 and then 1 from the other end of our molecule. So we have a total of 3 atoms of carbon here. Each carbon atom contributes 4 total valence electrons. So then 3 times 4 is equal to 12 total valence electrons coming out of the carbon. Now moving on to our hydrogens here, we have a total of 6 from the CH3 group. And then we have 4 from the other end, so 6 plus 4 is 10. We have 10 atoms of hydrogen. So 10 atoms of hydrogen, and then 1 atom of hydrogen gives us a total of 1 valence electron. So then 10 times 1 is equal to 10 valence electrons. And lastly, we have our nitrogen. So we have 1 atom of nitrogen here in our molecular formula. 1 atom contributes 5 valence electrons. So then 1 times 5 gives us 5 valence electrons. So then adding everything up, well, let's see here. We have 12 plus 5, that's going to be 17, plus 10 is 27 total valence electrons in our molecule. Alright, so we first draw a sigma bond framework as specified in our given condensed formula in our problem. So what a sigma bond framework is basically a connectivity of all of our atoms in the given molecular formula in a single bond only. And then we worry about everything else later on. So we have, let's see here, two CH3 groups connected to 1 carbon atom. So we'll just draw that 1 carbon atom first, then the 2 CH3 groups. And each CH3 group, of course, we have 3 protons or 3 hydrogens attached to that. So we have sort of a bulkier molecule going on here. Now that we have added the 2 CH3 groups, we still have 1 proton on that central carbon that we could say is central. We have 1 more proton there, and then we have a connectivity of the NH3 group. So we have an N with 3 hydrogens as well. Alright, so to determine the formal charge for each atom, we're going to go ahead and use this formula for formal charge. So we simplify formal charge just to Fc. So that equation here is going to be equal to, well, we have the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So that's the formula for formal charge. If we use this formula for all of our atoms here, we see that our nitrogen atom will have a formal charge of +1. Alright, so with that provided formal charge, then this completes our appropriate Lewis structure for our species of CH3 to CHNH3+.